Okay, so I guess we need to start now. Okay, others will join. Yeah, please. Okay, good morning.
Good morning, sir.
Loudly, good morning.
Good morning, sir.
Good morning.
Good morning, sir.
Yeah, great. जे झोपेत आहेत ते जागे झाले. Yeah, right. So today we are going to talk about unit number 2 for next 2 hours. So, in between, if you feel something going wrong, then you can take a rest, but you will not be allowed to go outside. Okay, you can sleep, you can do your own work, there is no issue. But in next 2 hours, I will be going to talk, you will be listening. In between, I will take one example so you will get some exercise. Okay, so you will get opportunity to apply your brain to solve something, right? And after this particular class, we will be completing our unit number 2 as well. Okay, so I hope we will be the first one who will be completing our first 2 units. आणि कुठल्या कोर्सेस झालेत का 2 युनिट्स नाहीत ना गुड नाही आपला संपत आलाय ना या राईट सो शॅल वी स्टार्ट
Yes, sir.
okay so today in this particular lecture we will be discussing feature selection. In that we will try to understand what is exhaustive, what is best first, what is greedy forward and backward. Here the greedy forward and backward is already discussed in our previous classes with some example forward chaining and backward chaining. So that concept we already discussed. So I will not be focusing there. And this content will be covered in first half, and in second half, that is in second class, we will be talking about various mechanical engineering applications where the feature selection and extraction how it carries out. Okay, so that you will get some flavor that even though you are a mechanical engineer, if we go to the industry as a maintenance engineer, so how feature selection and extraction will help you to do preventive maintenance or predictive maintenance. So these approaches, some flavor you will get. And as a design engineer also you will get some input. What should be your approach towards designing a system? Because traditionally we were just simply designing a component and putting into the application. Now days are changing. When you design a system, you need to think about how to do a maintenance. For example, nowadays sensors are available in the tires, and that continuously tell you how much air is there. And suppose air drops below some threshold value, then automatically you will get some signal. Yeah, and accordingly you can take some decision. So tire, that tube, that air is simple thing, traditional thing, but every time physically you need not to check how much air is there, so that we can make it smart. So that kind of application we will be discussing. Again, you might have heard about magnetic bearing, right? Yes, magnetic bearing.
Very yes.
Yeah, so we will be also taking one small example. Okay, so when we talk about search algorithms, so from the word search and algorithm, you can easily understand that there are n number of algorithms available to solve the problem, to select a feature, to extract the feature. And it is our duty to select a best search algorithm, right? For example, suppose you are started study of artificial intelligence and machine learning, so you may be interested to know which is best book for, right? So there are n number of books. If you search on Google books on AI ML, n number of books are available. So do you refer all those books? No. What you do, you ask your course teacher, you check in your syllabus which books are recommended. Again, in some of the online platform, you check for which book highest rating is given, right? And you shortlist some 10-15 books out of 1,000 books. And what next you do, you check the content and just go through the book, just quick look. And during that process you come to know, yeah, this particular book is very easy, English is understandable, so many examples are given, and you start referring that particular book. Again, if there is a local publisher who especially design the book related to our curriculum, then definitely you try to refer that book as well. So similarly in search algorithm we do the same thing, but the application may be different, right? So searching algorithms are designed to check for an element or retrieve an element from any data structure where it is stored. So suppose banking field is there. So a lot of information is there. For example, name of the customer, one type of feature, its account number, another feature, his past transaction, how much loan he has taken, how much credit he has, how much other information. So n number of customers and n number of data set. So suppose somebody applied for a loan. So directly you will not give, take this loan. No. You will check his old transaction. Previously he took a loan, then whether he paid back on time or not. So you will check his all track records, and based on that you will give or sanction the loan. Again question come, even if you want to sanction the loan, how much? Right, so for that you need to check what is its income, his income, how he, whether he filed the income tax return for last 3 years or not. So all these information we check and we make the decision. So for doing all of these activities we have n number of data set, n number of people, n number of information for all people. So we need to select the relevant information. So this is nothing but the searching algorithm. Again, another example could be the vehicle routing. For example, from this particular place, if you want to go to Delhi, so there are so many routes, right? You can go via Madhya Pradesh, you can go via Mumbai, Gujarat, that route. So there are n number of routes are available. So when we search the on Google Map, the starting point and the destination, it will show you the alternate way, right? And generally if there are two three routes, for example like this, what difference you will find in different routes? Time, right? So time is one of the parameter based on which you will see different paths. So the Google Map application is designed in such a way that it will provide you an option. Again, there are so many other options as well. If you pick a two-wheeler, different route it will show. If you go for four-wheeler, different, and train, so on. Right. So that much technological advancement we can see in India. Right. So when I was in USA, so suppose I wanted to go from this particular building to, let's say, the Madhukarao Pole Bridge, that is Nigdi Bridge, we call it, is right. So generally, how it shows, from this particular place where I should go, what where would be my first bus stop, and at that bus stop, at what time bus will come. Again, at what next stop I have to leave that bus, and again on that bus stop when next bus will be there. And when I will reach to the destination and a particular building, it will also tell what path I should follow, so that exactly at exact room I will reach. So that much accuracy was there. So what I wanted to convey here is that, see, the way we design the algorithm, that tells us or that helps a lot to do a proper decision. So, this particular vehicle routing or finding out the shortest path, the search algorithm could help. And the way the search algorithms are designed, that decide how optimally you can reach to the destination. It should not happen that you went to Delhi but you are looking for the final destination, you are asking for the people, where is this particular place? So what the Google Map I have seen during my postdoc, the you need not to ask anybody. Okay, Google Map only tell you, and if you miss any bus in between, then again it will re-modify the configuration and it will tell you when will be the next bus. So all modification, it will, even in India also, if you miss a particular turn, then it will remap and it will tell you from which next road you need to go. Again, take an example of process industry. For example, sugar industry is there, right? So sugar cane comes, it is crushed, chemical processes takes place, and different byproducts will come out, right? So during all these processes there is a chemistry. So chemical processes takes place, and the chemical processes takes place at a particular temperature, right? So there are so many factors, for example temperature, humidity, the material, the quality of raw material, the chemicals, the quality of chemical that we are using for the chemical reactions. So all these factors affect a lot on the quality of that sugar, which is one of the byproduct. So a lot of research can be has already been done at a particular temperature. If we carry out that process, the what would be the quality of that sugar? If a particular quality chemical is provided for the chemical reaction, what would be the quality of the sugar? So this is also an research where a lot of trial and error are made. For example, at different temperature the sugar is produced, at a different material sugar is produced. So you will have a lot of data set, and for that lot of data set an algorithm is prepared which tells us, if you have this particular raw material, if you have this particular temperature, humidity, then you will get best quality sugar. So this is the way of generating an n number of data set, and based on that data set we need to train machine learning algorithm, and that algorithm will tell you how to manufacture the sugar or how to produce the sugar. Is it fine? So data generation is one part, utilization of data is one part, and by utilizing that data developing the algorithm is another part, and based on that algorithm best find out the best solution for the given data set. Why this is very important? Suppose for a given data set if you prepared an algorithm, right, 20 degree, 30 degree, 40 degree, 50 degree still how is the effect on the sugar, but the quality of sugar that we get in sugar cane that we get in western Maharashtra, and the quality of sugar cane that we get in north India, the quality is different. Again there are variety of sugar canes, right? So same algorithm will not be helpful for all types of sugar canes. There should be a little deviation, and that is going to be a very big data analysis project. So there also such algorithm plays an important role. Again, there are n number of applications where you can apply search algorithm. For example, course and cost optimization, action planning, information mining, mechanical technology, and so many things. Even I will tell you, for example, right, in last semester you opted some major or minor, right? Yes or no? So there were three, four options. So what you did, you first of all ask yourself in which particular area I'm interested. You also ask various faculties, sir kashala जास्त demand आहे, what could be the future, right? And you gathered all this information, and based on that information your brain already developed an algorithm, and it provide you an outcome that you must go for either system engineering or vehicle and whatever other branch. Yeah, but when we talk about the algorithm that your brain has developed, that could be a limited one, because that algorithm is developed based on the information that you received from the syllabus when you ask information to the faculties. But if you go with the same syllabus to an international faculty, and if you ask the same question which is the best one, he may give you some different information, and for that information your brain could develop a different algorithm, right? So whatever information we receive, so based on that we can draw some conclusion. So these are the some of the applications where search algorithms are very important. And again, it is a location specific. whatever decision we make in India, same decision we cannot make in other countries. For example, when we construct a home in India, we generally don't think about providing an heater, right? Why we don't provide heater?
Already known.
Because our environmental conditions are that temperature is always most of the times above 20 degrees Celsius, right? So there is rarely any need of putting inbuilt heater in the house. But if you go to a north region or south region, extreme north or extreme south, in every home you will see an heater along with the air conditioning. So why? Because there is the need of that particular system. So there are n number of algorithms, there are n number of situations, and your role is to select the most relevant algorithm for a given application. Either it is a routing, either it is a chemical processes, either it is a cost optimization or any other thing. Again, when we talk about search algorithms, so basically there are two types. First one is uninformed or blind, and second one is informed search. From the word itself we can easily understand uninformed means for that particular algorithm we don't have initial information. And when we talk about informed search, so you will have some initial information. That's it. Again, in uninformed search algorithms, these are the different types: breadth first search, depth first search, then depth limited search, and so on. So, there are, you can see, six types of blind search algorithms. But good thing is that these are not in our syllabus. Okay, great. You are happy, right? And in case of informed search, when I say informed search means you will have some initial information with you. Again, in that there are two types: best first search algorithm and a star search. And in our syllabus only best first search algorithm is there. But in order to understand best search algorithm, first of all you should know about breadth first search and depth first search. And if you get some basic understanding about it, you can easily come to know about best first search algorithms, right? So again, the question comes, these are the only search algorithms? No. If you go to the literature you will see hundreds of such algorithms, because there are so many researchers who are continuously developing these algorithms. But our role as a student is just try to understand how that particular algorithm works. Here we are not expecting you to solve any complex problem. But of course, if you are interested in this particular course or algorithms, what you can do as a mini project or internship or a mega project, you can come up with a project. Yeah, so that could be a specialization. But again, in that, whatever contents we are studying in this particular course, all contents may not be important. But if you know the some fundamentals about each and every method, then during that project you can select, yeah, this particular problem we should go with this particular algorithm. And if you understand that, that is sufficient. Then you can go in details and learn that particular method in detail. So first of all, we will try to understand about uninformed or blind search algorithms, then informed search algorithms, and slowly we will move towards the best first search. Okay, so we will start with the blind search algorithms. So as I mentioned, so these are the general purpose algorithms, and where you will not have prior information, initial information you will not have. And again, we will be focusing on two methods only, that is breadth first search, BFS it is also called as, and depth first search, DFS. So we will try to understand how we should go. So as I uh, already told you one example, that if you want to go to Delhi, so you will have n number of routes, right? So you can prepare its tree. So Let's consider the example of breadth first search. So your starting point could be A, that is topmost, and your destination, let's say H. So you will find out different alternatives, right? And if you want to go reach to, let's say, destination D, so for this particular tree you will find out the path. If you want to reach to H, you will find out different path. So how this particular method works, first of all it will start with the top state, that is starting point. So let's say, just a minute, I will take a marker. Yeah. So initially one can start from here. So this is the first level, and all the alternatives are evaluated. Then after that the second level of alternatives will be evaluated. Then the third level alternatives will be evaluated. So in this way we go layer by layer. So we start from the first layer, then we go to second layer and so on. If such type of approach if we use to reach our destination or to identify how to reach the destination, then it is called as breadth first search. So it is also called as horizontal approach. Each and every time we find out first level alternatives. We will take one example. Suppose if you are playing a chess, and if it is your turn, then suppose you want to move a particular component. So what you do, you find out which are the places where I can put, right? And you put, make a decision such a that it will not get die, right? So that is your common approach. So this is the approach called as breadth first search. So find out all horizontal options and choose the best one where that component will survive. So this is breadth first search. Now second approach is depth first search. So DFS, it's not. And if you look at the animation you can easily understand how it works, right? So it takes a particular path and it will complete that path, then it will take a second path, it will go to the destination and so on. For example, if you search Delhi from this particular place, n number of path will be shown by the Google map, and if you click on one of the path, it will tell you how much time it will take to reach that particular place. If you take another path, then it will tell you the time. So you will evaluate each and every route and then decide which route will you prefer. So this is called as depth first search. So depth, from the word depth itself you can understand how to select a path. So 1 2 3 and 4, this is one path, then this could be another path and so on. So, is there any question related to breadth first search and depth first search? Simple, looks easy, and this much understanding is sufficient, right? Now, in case of informed search algorithm, so many things are there. Okay, so informed search uses problem specific knowledge. For example, your destination is Delhi, so you need to reach there. So problem is clear to us, and accordingly the decisions are made. Okay, again you may sometime need to play with lot of data set. For example, if you want to go to Delhi, then you will find out alternatives. If I go by a car, how much you have to pay. If I go by aeroplane, how much you have to pay. And accordingly you find out all the options and you make a decision, that is which is the best route through which I can reach that. So there are so many information I put in the slide. I will not read all the information. The reason is that when we take an example, you will come to know more about it, right? But the previous slide, the fun days are clear. When we say depth, a particular route is followed, different alternatives are evaluated, and in case of horizontal approach, at every level we study. Yeah, here the informed search algorithms are also called as or a kind of heuristic approach. So this could be a new word for you, but it is related to informed search algorithms. So here what you can see, when we say uninformed, so what I said, you will not have any data. So you will find out all the alternatives. But when we say informed, so you will know the destination. So in this particular figure, you can see your starting point is yes and your final point is E. And there are different routes through which you can reach to your destination. Now question comes, which route will you prefer and how will you put different numbers at different levels in order to make a decision. For example, if you want to start from yes and if you want to reach to, let's say, C point, then we can say whatever below yes 10 is written, let's say that is a ticket or that much amount you need to pay, and whatever written in the path, that could be the distance to be covered, let's say. So now tell me, if you want to start your journey, whether you will go to B or C, where will you go? Yes, are you agree with B? Why? Because the ticket is rupees 10 but the distance is short, so definitely you can think of picking that particular, yeah. So this is first layer in which you pick the layer B. Now similarly what you can do, you can find out the cost for different routes. Okay, so this is the one route. So by using the ticketing charges as well as distance, you will find out the balance between the cost and time. And you can compare different plans. So second route could be this one. And there is another route. There are so many routes basically. So for each route, you will find out the alternatives, how you can reach to the destination, and that will be your best. So such type of problems can be solved by using informed search algorithms. Again we will go to greedy best first search algorithm. So it is the combination of both, that is depth first and breadth first. So many information is there, I will not go into that. Okay, you can read afterwards, because I have mentioned there are so many things and it may be a boring, but yeah, we will take one example. Right. So just like the previous example, this is another example where this is a particular path or tree is there, and here for as a b, here directly values are not given, it is given in the tabular form, where hn is a heuristic value or heuristic number, and the for a given node the corresponding value is given. So in previous example we saw that we consider the arrow or the length as a that particular path number, and whatever notation is there in the node, the corresponding number will be the cost. So can anybody tell which will be the best path to, or what will be the optimum way to reach the G? Yeah, how will you reach to G? S B F G. Can we use path S A C G? Can we use? Why? There is no arrow, so we cannot reach. But why that arrow is not there? Any answer? Why that arrow is no, any arrow is not there? We can draw an arrow, right? But why there is not an arrow? See, example is same, but I am trying to tell you some different information. Why there is no arrow? That much data only, yeah, that could be the reason. Any other practical correlation?
ऑलरेडी हे तीन आहेत ते शॉर्ट आहेत जास्त आहेत म्हणून नाही.
Yeah, that is fine. You identified because a simple problem. But I am just trying to tell you about some alternative. Red color, that arrow shows that could be another path through which you can reach to G. The answer could be whatever tree you develop, you consider certain parameters. For example, if you prepare this particular tree by considering you are traveling by a road, right? So this particular tree will be for that. So why you can't connect C and G? There may be any, there may not be any road route via you can start from C and you can reach to the G. So this example will tell you when you get a particular type of tree, you make certain assumptions prior, and based on that you prepare. And whatever tree you will prepare by using the travel time, let's say here, and corresponding cost as a heuristic value, you will find out the optimum path. So this is how you will start your journey, right? One by one. Okay, so we will go ahead and now you have to solve one problem, right? So draw this particular puzzle problem. Okay, and in 3 4 steps we will solve this particular puzzle. So there are total 8 blocks in this, and out of which one is blank and others have some numbers, right? And this is the yes means this is the initial state. आपण क्यूबचं सोडवतो ना, सगळे कलर एका साईडला म्हणजे ज्या त्या कलरचे सेपरेट झाले पाहिजेत. सेम असा प्रॉब्लेम आहे जो आपण ग्रेडी फर्स्ट अल्गोरिदमने आपण काय करणार आहे, सॉल्व्ह करणार आहे. ठीक आहे. सो वॉट एव्हर बॉक्स यू कॅन सी हिअर, दिस इज अ स्टार्टिंग पॉइंट. Okay, and when you solve this particular problem, you will come to know how this particular approach works. Did you complete? So this will be your initial state, and this will be your destination or final state. ठीक आहे. तुम्हाला काय करायचं आहे, अशा पद्धतीनं नंबर्स अरेंज करत जायचं आहे की तुम्हाला काय झाली पाहिजे, ही स्टेट रीच झाली पाहिजे. ठीक आहे. म्हणजे सुरुवातीला तुमचा ब्लँक कुठे आहे, इथे आहे. ठीक आहे. आणि तो कुठं आणायचा आहे तुम्हाला, इथे आणायचा आहे. आणि ॲट द सेम टाइम what you have to maintain, 1 2 3 4 5 6 7 8, that sequence you have to maintain. So tell me, initially which moves you will start with? You will interchange 4 and then blank.
Yes.
Why?
Because then you can take 5 and 4 and all.
Yeah, true. Means there are different approaches as well. I can interchange these two, right? I can interchange this one also. Possible or not?
Yes, possible.
Can we interchange these two? So initially we can have three options. Now question is, which will you prefer? So logically your answer is correct. We can interchange these two because this particular block is close to this. But this is a simple problem where you can easily come to know. But if it is a very complicated, suppose there are some other blocks here, there are some other blocks on upper side, and so many blocks are there, and 2 3 blank places are there. So in that case, this simple approach will not work, right? Here logically you can say. So we will try to understand the same thing in mathematical way. Suppose we interchange one and that blank place, right? So if we decide to go for this particular move, I can compare this particular new position with my destination, and I will check how many misplaced numbers are there. So 2 is at right position, 3 at right position, 1 1 and 4 are they at right place? No, so first misplace is there. What about 4? Here 4, here 5 is second misplaced. Next one is 6 and here 6. So it is correct position. 7, 7 correct position. Here 5 and here 8. So this is third misplaced position. And again here 8 and your final destination misplaced. So when you compare the new state to your destination, how misplaced numbers are there? 4, right? So the heuristic value will be 4. So what you do now, you need to draw this block, draw this particular block, and manually check how many misplaced positions are there, and verify that the misplaced number is equal to 4. Do it. Do it. Draw the same diagram and just verify whatever h equal to 4 I received. Are you agree with it or not? Okay, start. I will repeat once again. This is a new position. This is our destination, right? So I will check which are the numbers as per the destination and which are the number which are not as per the destination. For example, here we are expecting blank, but in our new position it is 8, so first misplaced number. Here we are expecting 8 in final destination, but here we are getting 5, so second misplaced number. Here it is 7 and in destination also we are expecting 7. So absolutely fine. And when we talk about 4, destination we are expecting 5. So this is third misplaced position. And similarly, here we are expecting 1, but there we are getting blank. So this is fourth blank position. And rest of the numbers are as per the destination. Okay, so do it. Everybody has to draw this and check whether you are getting heuristic value as 4 or not. If you think it is not, then you can ask. सिम्पली इथे काय करतो आपण की एक मूव करतो आणि चेक करतो की डेस्टिनेशनच्या किती आपण जवळ गेलेलो आहोत. ठीक आहे, आणि जितकं डेव्हिएशन असेल ते म्हणजे त्याची काय असेल, हेरिस्टिक व्हॅल्यू असेल. यस, जितकं डेव्हिएशन तितकं तो नंबर, तो जो काउंट भेटतो नंबर ऑफ मिसप्लेस, तो नंबर म्हणजे हेरिस्टिक व्हॅल्यू. म्हणजे त्या डेव्हिएशनसाठी आपण नाव दिलेलं आहे हेरिस्टिक व्हॅल्यू. Now here what we did, we interchange these two positions. आता काही जणांनी काय सांगितलं की आणि सर 2 मूव पॉसिबल आहेत. कोणत्या? ही एक मूव पॉसिबल आहे, राईट? तर हा मूव तुम्ही करा आणि त्याचा करस्पॉन्डिंग ब्लॉक करायला जमेल का तुम्हाला? असं ब्लॉक करायला जमेल? ब्लॉक तयार करा आणि त्याची हेरिस्टिक व्हॅल्यू कॅल्क्युलेट करा. डू इट. इनिशियल स्टेट इज देअर. आता काय इंटरचेंज करणार आहे आपण? ब्लँक आणि तो 4 हे इंटरचेंज करायचा, नवीन असा बॉक्स तयार करायचा, आणि किती नंबर्स मिसप्लेस्ड आहेत ती म्हणजे काय असेल त्याची हेरिस्टिक व्हॅल्यू. सो स्टार्ट. Yes, heristic value is how? 3. We need to compare these two. We need to compare with the destination. Destination is G. Ah, yes. 2. No, no, this is the value. Right. 2, 3, 4, 5. But we need not to consider that blank. Okay, so second, what is the heuristic value? 2. 2. Are you sure?
Yes, sir.
2 or 3? Do not consider that blank. Exclude that blank and tell me how much. 2. Now do the next task. Interchange these two, blank and 7, and prepare another box. 4. Are you sure? सगळ्यांना भेटतो का 4?
Yes, sir.
Yes? Okay, we will check. So, when I move in a downward direction, 7 and blank, I will get heuristic value 4. Is it correct? म्हणजे माझं पण उत्तर बरोबर आहे. Again, if we interchange the blank and the 4, that is right shift, you will get another. Now, how many alternatives you have? 3, right? So, when we compare these three heuristic value, and if we compare with the destination, which is the best move? Which one? Right one. So, before we did this, you told this particular is the best move, yes or no? Yes. So, whatever mathematics we did here, you already did in your brain. Yes or no? But you don't know. So, what we are doing, what our brain process, the way our brain process, we are just doing mathematically. That is the approach. Now, at next level, what you can do, you can have different approaches. So, tell me now where you will shift this particular blank place. So, you can interchange this one. Can you do it? So prepare one box and compare with the destination and check what is its heuristic value. So I guess there are 4 ways we can shift that blank, right? So for all 4 possibilities, you can prepare that box.
One is this.
Yes?
One.
1. Are you sure? Yes. Yes? 1. If you got the answer, you can go for another alternative. So move towards right. Then you can go for interchanging 4 and the blank place and again 2. So there are 4 alternatives. So try with all alternatives. Okay, those who don't understand yet, so I will tell you them once again. So presently the blank place is here and our destination is here. So we need to reach that particular part. So either we can interchange the blank and the 6. This is one option. Second option, we can interchange the blank and the 5. We can interchange 4 and the blank. and we can interchange with 2. So 4 alternatives we can have. Yes. So डाऊन, आता मी केलेलं आहे बघा काही ठिकाणी. माझं आता चेक करा माझी उत्तर बरोबर आहेत का. डाऊन केलं की हेरस्टिक व्हॅल्यू भेटते 1. भेटते का? राईटला किती भेटते? येस, आय एम ऑल्सो करेक्ट. लेफ्टला 3. करेक्ट. अपला 3. Yes, so I am also correct. I also tried this example, but I was doubtful. Okay, so you confirm my I am also correct, right? So first level we did something, we come up with the best option. In second level we tried different alternatives, and which one is the best? This one, down. Yeah, great. So now for this down option, again you can try out different alternatives, right? So this is the, just a minute, yeah. So we will start with this particular approach and try out. So how many positions are possible? Yeah, left one option, right another option. We will not go to up because we already did it. But you can do, huh? No problem. You can do it. And tell me and compare that these new positions with our destination. Okay, when we take a left switch, that is 7 and 7 to interchange with 7. What is the nearest value? 2. And when we go to right, 0. And is that your destination? Yes. Oh, really? Okay, so when you compare your destination with right one or left one, which one? Right one. Okay. So this is your destination. So do we need to go ahead? No. So your goal state is achieved. Fine. So this is how your brain works, right? So it's just a mathematical way of putting on the paper. But there is one very interesting thing that I wanted to tell you here. First of all, I will go to one of the slide. I will tell you that point and then again we will come back here. Yes, here. Here what we did, we go by layer, right? And here we go by a particular path. True, two different approaches. Now when we solve this particular puzzle problem, what you did? What you did? Layer by layer. If your answer is layer by layer, your answer is both. Why layer by layer? Why both? And yeah, before that, I will make one more story. In one of the slide, I run many slides, right? And there in one of the slide, I said best first is a combination of both layer by layer and a particular route, right? So somebody is saying it is a mixed approach. Somebody is saying it is layer by layer approach. Which one is correct? Mixed. How many of you are in favor with mixed approach? Raise your hand. One, two, three, four, five. How many of you is saying layer by layer? One, two, three, four. राहिल्यांचं आमचं काही मत नाही. Ah, sir, you make your own decision. It means you are not in the flow. Okay, that's fine. See, when we say layer by layer, so from first state to the first layer, we identified three combinations. So we investigated first layer, all blocks. Now, when we go to the next level, here also you can have different alternatives, right? Don't worry about this heuristic value. Forget about heuristic value. When you consider this particular state, do you have different options? Yes or no? Two options you have. Which one? Either you can interchange this one or either you can interchange with the two. Yes or no? So two options you have. If we take this particular situation, again you will have two options, interchange with 7 or interchange with 5. So again you will get two more lower level alternatives. Again, when we talk about this particular state, how many options you will have? 4. So here 2, here also 2, and here 4. How many alternatives you will have? 2 plus 2 plus 4, how much? 8. So here you can draw 8 different types of boxes. Yes or no? But did you evaluate all those? No, right? So when we talk about first layer, you check all the layers. Sorry, all the box in that layer. But when you go to the next layer, you are dealing with only these four. One, two, 3, and 4. Yes or no? So those who are correlating with this particular layer, they are saying, yeah, we are going layer by layer. But actually, we are using hybrid mode. So at first layer, there was no option to going with particular. We need to go with all the options. But the heuristic value will help us to decide the optimum conditions, and that's why instead of 8 we go with the only 4 options, right? So this tells us that we neither went with the breadth first or depth first. Here we went with the mixed approach, and that's why it is called as, what is the name? Isarla Kai. West first. Yeah. Is there any question related to this? Was it interesting? Right? So why we took this particular example? If I started with theory only, you may sleep, right? But this particular example will tell you the how this particular approach works, and you will reach to the destination, right? So similarly, yeah, this is just the explanation of that. Okay, we already solved this example, and this is how you will come to know. Okay, so what time is it? 10. So 10:10. Okay, so we have some more time. Okay, and now we'll be starting with our last part, feature selection and extraction, mechanical engineering applications. Okay, so is there any question based on whatever we discussed? No. There could be one question. You may not be in a position to take a particular mechanical engineering example, right? That could be a question. We solved that puzzle. We understood. But till we don't have any example related to mechanical engineering applications. Right. But our ultimate goal is to understand the fundamentals. When you start working on a particular project, and if you come across certain situation, then you can use those algorithms. Now, we will try to explore how the feature extraction and selection techniques are useful for mechanical engineering problems. So let's start with first example. Okay, and it's about maintenance. When we say mechanical systems, maintenance is very important. Yes or no? Without maintenance, is it possible to run the system? So, can anybody tell the example in which maintenance is essential? स्पेसिफिक सांगायचं मशीन मध्ये असं म्हणायचं नाही. टू व्हीलर मध्ये कुठे कधी yes. So you change the oil in the two wheeler or four wheeler or in a machine at regular interval. So it is a corrective maintenance or predictive maintenance or preventive maintenance. Preventive. Okay. So that is one example. Another example, bearing lubrication. Is it predictive, corrective? What type of maintenance? Preventive. तुमच्या गाडीचं टायर पंक्चर झालं, रिपेअर करणार ना. व्हॉट टाईप ऑफ मेंटेनन्स इट इज? करेक्टिव्ह ऑर ब्रेकडाऊन. तुम्हाला सांगून पंक्चर होत नाही ना ते. अनएक्सपेक्टेड, इट इज अनएक्सपेक्टेड, सो इट इज कॉल्ड ॲज ब्रेकडाऊन. ठीक आहे. वेन यू परचेस अ न्यू टू व्हीलर और फोर व्हीलर, यू विल गेट सम फ्री सर्व्हिसिंग. येस और नो? कुणाला आहे अनुभव? नसेल तर नवीन कार विकत घ्या, गाडी विकत घ्या, यू विल गेट दॅट. ओके, यू विल गेट वन मॅन्युअल, अ बुक इन विच इट इज रिटन from the date of purchase. When you travel between 500 to 750 kilometer, you go to our maintenance shop service station and free servicing will be given to you. After that, when you will travel 1000 kilometer to, let's say, 1200 kilometer, I exactly don't remember the number, but at that time also go to the service station and you will get free servicing, right? So it is also maintenance, right? So, is it a preventive, predictive, or breakdown? Or is it a predictive? Predictive, right? So, companies know when failure may occur. That's why they come up with that number. So, they might have some background study, and based on that they decided that interval. असं म्हणत नाहीत की कधी या तुम्ही, नाहीतर तुम्ही 10 वर्षांत जाशील करा दुरुस्त. दे विल नॉट ॲक्सेप्ट. दे विल गिव्ह अ रेंज अँड, आणि त्याच्यानंतर जर गेला तर ते नाही करत मेंटेनन्स. इट इज एक्सपायर्ड म्हणतात. अगेन 500 to 700 किलोमीटर हे एक युनिट झालं. दुसरं एक युनिट असतं किती, 100 दिवसाच्या आत, 80 दिवसाच्या आत येऊन करून द्या. सो दॅट मेंटेनन्स टाइम इज एक्सप्रेस इन टर्म्स ऑफ किलोमीटर्स as well as in terms of days. So in both ways it is expressed. So that is also very interesting part. So their reliability engineering come into the picture. So I will not go in that detail, but yes, of course, maintenance is one of the important part. And we will take the example of magnetic bearing. So can, is this figure visible to you? Right? So anybody knows how magnetic bearing works? Anybody? Have you heard about magnetic bearing? Have you heard about bearing? Yes. Oh, thank you. Now tell me, which are the different types of bearings? Ball bearing. So generally we call it as a deep groove ball bearing. I also know something, huh? Even though you studied in last semester. Okay. And again, roller bearing or taper roller bearing. Again, thrust bearing. So many types of bearings are there. एक एक असे बेरिंग असतील की तुम्हाला ते बघितलं तर वाटणारे नाहीत की ते बेरिंग आहेत, पण ते बेरिंग असतात. ओके. So magnetic bearing is one of the type of bearing. So when we talk about ball bearing, roller bearing, thrust bearing, there is a direct contact between the shaft and that bearing. म्हणजे तुमचा पेन आहे कुणाकडे? जर तुमचा शाफ्ट असेल तर त्याच्यावरती काय असतो, बेरिंग हा फिट केलेला असतो. सो देर इज अ डायरेक्ट कॉन्टॅक्ट. ठीक आहे. आणि बेरिंगला काय असतात, इनर रेस आणि आउटर रेस असतात. आणि शाफ्ट रोटेट झाला की इनर रेस फक्त रोटेट होतो, आउटर रेस काय असतो, स्टेशनरी असतो. सो दॅट इज द बेसिक अप्रोच विथ ट्रॅडिशनल बेरिंग. मॅग्नेटिक बेरिंग मध्ये तसं होत नाही. मॅग्नेटिक बेरिंग मध्ये तुमचा जो शाफ्ट असतो हवेतच रोटेट होतो, कुठल्याही प्रकारचं कॉन्टॅक्ट नसतं. सो यू कॅन सी इन द फिगर. सो whatever part I highlighted here, it is a coil. आणि शाफ्टच्या काय तर सर्कमफरन्स वरती तो कॉईल आहे. आणि अँड इलेक्ट्रिसिटी इज पास्ट. इलेक्ट्रिसिटी पास केली की काय होणार, मॅग्नेटिक फील्ड विल बी क्रिएटेड, राईट. सिमिलरली यू विल सी कॉइल्स हिअर ॲज वेल. दिसतात का? अगेन इट इज circumferential, right? But the difference is, here you can see the shaft outer diameter and how the coils are placed. And when we come here, there is a larger diameter of the shaft here, and both side there are coils. And therefore, these are the two different types of bearings based on their arrangement. So when we talk about this particular shaft, and when we assume that the shaft is rotating in the air, there is no support, then what may happen? This particular shaft may move axially, yes or no? असा मूव होऊ शकेल की नाही? पॉसिबल आहे. Again, that shaft can move in radial direction as well. Yes or no? So, give it once again. So, when we talk about this shaft rotating here, it may move axially. So, there should be an axial bearing, right? That axial movement must be restricted by that axial bearing. So, whatever coil you will see here, they created a magnetic field, and their role is to restrict the axial movement. Again, when we talk about this shaft, it also moves in radial direction, either up, down, to, fro, or inclined direction. All radial direction movement is also possible. So, whenever I talk about this particular coil, this coil will create a magnetic field so that the radial movement, either up, down, to, fro, or inclined direction, will be restricted. Can you imagine this particular technology? Very interesting, no? So only magnetic field is there, and that is allowing the shaft to rotate in the air, and it is also restricting the axial movement as well as radial movement. So the question comes, if the shaft is rotating in the air, so there is no friction. So if there is no friction, so there is no limitation to the speed. So can anybody tell what could be the maximum speed that you have seen related to shaft? Talk about regular shaft. Okay, where regular ball bearing or other bearings are used. How much maximum speed you have seen? Electric motor, how much is the speed? अरे माहित आहे की नाही तुम्हाला? When we say इलेक्ट्रिक मोटर, जी तुमच्या घरामध्ये असेल, पाणी वगैरे उपसायला वगैरे वापरत असाल, बोर असेल, बोरवेल, किती असतं स्पीड? पॉवर झालं 1 HP. व्हॉट इज द स्पीड ऑफ दॅट मोटर? जनरली 1440 RPM इज अ स्टँडर्ड. मग 1500, 1400 हे थोडंसं असतं. अगेन स्टँडर्ड असतात या रेंज. अगेन यू कॅन सी अ 750 RPM अँड क्लोज टू दॅट as well. Okay. Again, in some application, I have seen speed up to 5000 RPM, but that is in case of our regular bearing, right? But when we talk about magnetic bearing, so I have seen a compressor of Danfoss company whose speed is 50,000 RPM.
10 times.
Yes, yes, yes. 50,000 in front of that tree, triple zero, and RPM means in 1 minute, how many revolutions will be there? 50,000. So, can you imagine? Again, in our four wheeler, have you heard about turbocharger? Just search on Google what is the maximum speed of that turbocharger if magnetic bearings are used. You will see up to more than 1 lakh RPM. Can you imagine? Can you imagine 1 lakh RPM? एका मिनिटामध्ये 1 लाख रोटेशन होतात. And when I was talking about that Danfoss compressor, इथं कॉम्प्रेसरला इथं जर चिटकून जर राहिला तुम्हाला आवाज सुद्धा येणार नाही की तो कॉम्प्रेसर चालू आहे की बंद आहे. इंटरेस्टिंग ना. So this is the magnetic bearing. So what I wanted to tell you here is that if this is the magnetic bearing, if that shaft is rotating at 50,000 RPM. So the question comes, if something happens to this coil and if that bearing fails and if shaft moves in axial direction or radial direction, what a damage it can do. 50,000 RPM. आणि
per second 840 कुछ तो रहेगा ना.
yeah, that is mathematics. You
सर
can
बट
do.
एक सेकंड इतना राउंड
Yes.
एक सेकंड में वो 840 टाइम्स रोटेशन.
Your question is, it is not practically possible?
Yeah, it's a bit tough to imagine.
Then go to Google and you can search whatever example I have said, turbocharger and Danfoss compressor. You can search on Google and you will see in practical application they are there. Right. But we should not deviate from our main topic. Right. So we'll stick to our main topic that I wanted to convey. But whatever example I told you, you can search on Google and you can verify. And if you found that is a wrong example, you can say, sir, whatever you are saying, it is wrong. I will accept.
I mean, it is not impossible, but it's difficult to
It is
imagine.
possible. I'm saying that is practical applications, and I'm trying to tell you here what will happen if this bearing fails. Right. So we will go ahead. So imagine if something happens to this bearing. Suppose there is no magnetic field. What will happen? That shaft move either in radial direction and axial direction, and it can damage just like anything.
It lasts not that
So
speed.
first of all, listen to me. When I will complete, then I will take your questions. Okay. So it can damage just like anything. And as a design engineer, your role is to design that magnetic bearing such that it will restrict its axial movement as well as radial movement. But even though there is a magnetic field, there is a slight axial movement, but that is in microns. There is also a radial movement, but that is also in microns. So we discuss in the decision tree to split the data, right? So for axial movement, a cutoff is set. For example, if the axial movement is beyond 20, let's say, I'm assuming 20 microns. If that axial moment is beyond 20 micron, what your system will do? It will trip the compressor or it will stop the shaft. Because if the axial moment is beyond 20 micron means something may happen, accident may takes place. So system will take care of that, something serious issue may come, so we should stop. Similarly with the radial movement, again there is a cutoff that if axial so radial movement is beyond a certain value, let's say 50 micron, then automatically your system will stop that shaft. Right. Why this is very essential? Because shaft is rotating in the air, and if something go wrong, accident may happen. And for that, the machine learning algorithm, the decision tree, everything will come into picture. How? So first of all, we need to test such shaft for the magnetic bearing. and practically in the experimental setup, and you need to find out that how much axial movement is happening, and not for a single time. You need to find out its behavior over the period of time, because whatever magnetic field you will be receiving today, after 1 year will you get the same magnetic field? No, there is a degradation, right? Of course there will be a degradation. So that study you need to do, and you need to find out a cutoff, that if the axial moment is beyond certain value, stop the system. If it is below that cutoff value, continue the operation. So the splitting of the tree based on the cutoff value. Are you getting application of decision tree? So this is how there is a sensor, you can see here. So this sensor makes sure that, or this sensor continuously measure how much radial displacement is there with the rotor, and that information is continuously received at the controller, and controller make the decision. If the radial movement is within limit, continue the operation. If it is beyond limit, it will send the signal and this particular rotor will stop. Similarly, there will be a sensor somewhere here close to here on both sides, that will continuously measure what is the axial movement of the shaft. If it is within limit, the controller will say continue the operation. If it will go beyond certain limit, it will stop. Are you getting? So finding out that cutoff range and splitting the data, either continue the function, stop the function, this is the application of AIML in controlling the movement of the shaft, right? Getting? And here, axial movement of the shaft is one feature, radial movement of the shaft is another feature. So, feature extraction. So, when we talk about shaft, if it moving in axial direction, accident may take place. So, this is one feature we identified. If it is moving in radial direction, up, down, to, fro, this is another feature that we identified. हे सोडून कुठला आणि movement असतं का? नसतं ना. So when we say shaft, only two features that we extracted. And in order to have a controlled or safe operation, we prepare a decision tree based on a cutoff value for axial movement, radial movement. Any question related to this application? Now I will take your questions. But did you understand what is feature in this? Did you understand how to extract it? Did you understand how to split the data in order to have a continuous operation or discontinue the operation? Any question? Is it interesting? So when you get time after this lecture, just search on Google Danfoss compressor. Okay. And I visited a industry in Aurangabad, and with my friend who was doing the maintenance of this compressor, and I have seen, I was just next to that compressor, and my friend asked me a question in 2011. Tell me whether that compressor is working or not. And I said, I don't know. And he asked me, are you a mechanical engineer? So this is something very interesting concept, and you can read it more. So that's why purposefully I brought this example, so that you will come to know what is mechanical engineering in this, and how AIML plays an important role. One more important thing I would like to highlight here. See, I said that the performance of this magnetic bearing will degrade over the period of time. But during operation also, how that magnetic bearing works based on electricity supply, right? Which is taken from the either state electricity board or through the generator. And it also fluctuates. And if that electricity fluctuate, magnetic field also may fluctuate, right? Yes or no? It will also affect on the axial and radial movement. So that parameter also considered. Yes or no? So,
So it will not be neglected
hmm?
because those fluctuations may not affect the log of the magnetic field. No, sir.
Can you please repeat your question?
No, sir. You said that this will affect, long time degradation will happen. But those fluctuations in the electricity is not as, not so strong to affect the magnetic field, right?
See, two things are there. Over the period of time, there is a degradation that we need to consider. That is one feature you need to consider while designing this particular magnetic bearing. Because as a magnetic bearing manufacturer, if I say the warranty is only 1 month, will you buy? But if I say warranty is 10 years, will you buy? Yes. So that degradation over the period of time is an important feature must be considered in order to sell your magnetic bearing. But the external parameter, that is electricity which is supplied to that bearing, it is not even a hand, because it is supplied by the state electricity board or the generator set that the company has. And electricity fluctuation is also important parameter. So this particular system, this control system also consider that part also. If there is a fluctuation in the electricity input, so again the shaft may move axially beyond certain limit. So immediately the system will stop. Trip. Clear? So is it clear application of AI ML in mechanical engineering? Interesting? Okay, read more. Let's take second example of reliability prediction. Okay, first of all, I will put everything in front of you. I hope this particular straight line is visible to you. I hope. Is it visible to you? Even though it is not visible, assume that it is visible to you. Okay. That is a joker. Okay, so reliability prediction. So, what is the life of human being?
80 years,
80
70
years?
years.
100 years?
Sir,
No?
according to Google, it is 60 to 70.
According to Google, very good. Good answer. Any other answer?
Because a lot of relatives are 80, 90, so I can't
80,
say.
90. So practically you cannot say what is the life of you, yours. तुम्ही सांगू शकाल नाही मी 100 वर्ष जगणार सांगू शकता कोणी कॉन्फिडेंटली. सी लाईफ इज अनप्रेडिक्टेबल. येस और नो? If our life is in unpredictable, whatever laptop, cell phone, systems we are is it predictable?
Yes, sir. We know the lifespan of a metal and what are the factors affected. So we can calculate how much time we can exist or to which we can use.
Okay, you can predict. But my question is, tell me what is exact life of a cell phone? When I say predicted means I am talking about a single value. जसं मी म्हटलं की माणसाचं आयुष्य किती आहे. Are you confident about 80 years, 60 years? No. Are you confident about then machines? No. We can say, yeah, human can live between 60 to 100 years. बेटर आन्सर ना. एखाद्या विद्यार्थ्यानं जर सांगितले की नाही ह्युमन 80च वर्ष जगतो, नाही पटत. पण 50 ते 100 वर्ष जगतो, हा ठीक आहे, त्यापेक्षा हे चांगलं उत्तर आहे. सो देर इज नो फिक्स्ड आन्सर.
Sir, but we can say that if the no external factors affect, this can 100% be
But that
lifespan.
is the ideal condition.
Yes, sir.
We are not talking about ideal condition, we are talking about the real systems.
Oh,
So, what I'm trying to tell you here is that when we talk about mechanical system or any other system, even living organism, life is unpredictable. But we need to find out certain parameters based on which we can do some a better prediction. Better prediction. फॉर एक्झाम्पल, समजा तुमचे आजोबा पणजोबा किंवा तुमचे चुलत आजोबा जर समजा 80 वर्ष सरासरी जगले असतील, सरासरी और 70 to 80, सो कॅन एक्सपेक्ट की ॲटलिस्ट आय विल रीच देअर. येस और नो? सो दिस इज द वे ऑफ प्रिडिक्शन. You may go wrong, but there is no other way. Based on previous data, we can predict. So same example we will take here, and that will try to connect with AI ML, feature extraction and selection. So do not deviate. Try to understand example, but do not deviate from the feature extraction and feature selection. So in this particular reliability prediction example, what we did, we have four batteries B1, B2, B3, B4, and we test these batteries in the laboratory for its life. So, how to express life of a battery? So there are two units. One is in kilometer, in cycles. How many times it charge it and discharge it. So discharge charging is one cycle. Second time charging discharging second cycle. So it will have some cycles, number of cycles. आणि काही सायकल झाले की असं होईल की आता ते चार्ज पण होत नाही डिस्चार्ज पण होत नाही चार्ज झालं तरी हार्डली एका दुसरा तास चालतं सेलफोनच्या बाबतीत होतं ना सुरुवातीला 2-2 दिवस चालतं हळूहळू कमी 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 होत ज्यावेळी ते 2-3 तास चालतं त्यावेळी म्हणतं की अरे आता बॅटरी बाद झाली वी विल रिप्लेस इट येस ऑर नो सो सिमिलरली वी टेस्ट द बॅटरी इन द लॅबोरेटरीज and the failure criteria is its capacity residual capacity. So for battery B1, the experimental told us the life is 1259 cycles. Similarly for second battery, third battery, fourth battery. So there are four similar kind of batteries and their corresponding life is given. So we have data points. We talked about regression, yes or no? For example, straight line, what we do? We fit a straight line equation y is equal to a plus bx, that is one model. Can we fit a second degree parabola? Of course, we can fit. Y is equal to a plus bx plus cx square, second model. Can we fit an exponential model? Of course, we can fit. That is another model. Similarly, here you can see Weibull three parameter probability plot. So Weibull is another model. Have you heard about normal distribution? That is another model. Have you heard about exponential model? That is another model. So there are different models: straight line, second degree parabola, exponential, normal, Weibull. These are the models. So here we are fitting the given battery data to a model name is three parameter Weibull. Okay, so you can see it four data points. इथे दिसतात का तुम्हाला हे डेटा पॉइंट्स म्हणजेच बॅटरीचे लाईफचे आहेत and we fit a straight line for the given data set and when we fit a straight line to it you will get some equation जर तुम्ही स्ट्रेट लाईन फिट केली तर तुम्हाला कुठलं इक्वेशन y इज इक्वल टू a प्लस बी एक्स yes where a is coefficient y is another means these are the two basically unknowns that we find out. Similarly in case of Weibull, when we talk about Weibull, beta, this eta and this gamma, these are the three parameters because for this particular data set we are fitting that data to that model and we are getting these parameters. So your model will be ready. ठीक आहे हे जे काहीतरी कॉम्प्लेक्स मॉडेल आहे राईट काय क्वेश्चन आर टी इज इक्वल टू ई रेस टू मायनस टी बाय थिटा रेस टू इटा ठीक आहे लक्षात राहणार नाही म्हणून मी ते लिहिलं पण नाही इथं इथं आपल्याला लक्षात काय घ्यायचं आहे की वी हॅव अ फेल्युअर डेट ऑफ बॅटरी वी फिटेड टू द Weibull model we received its parameter and this is the correlation coefficient. And I told you many a times, when correlation coefficient value is close to 1, model is very good. Yes or no? If it is close to 0, not good model. Right? If it is close to -1, it is also good model. फरक काय असतो जर तुम्हाला अशी स्ट्रेट लाईन भेटली अप ट्रेंड यू विल गेट कोरिलेशन कोएफिशिएंट क्लोज टू 1 आणि बरोबर उलटी लाईन जर भेटली इट इज क्लोज टू मायनस दॅट इज द डिफरन्स. But here you can see that the all the data points are close to that straight line and correlation coefficient is close to +1. So this is the best model. Now here what are the features? ठीक आहे हे कळलं सिंपल मॅथमेटिक्स काहीतरी आहे बट व्हॉट इज फीचर इन दिस केस so my Weibull distribution is one model Exponential is another model, straight line is another model, second degree parabola is another model. So different models are there. Can we consider these are the different features? If we call these are the features, then correlation coefficient will tell you which is the best model. Means for all these models, the model for which you will get value of correlation coefficient very close to 1, plus 1 or minus 1, that will be the best model for the given data set. So we can say that this is the feature selection. If we consider model as a feature, but we will go ahead and we will try to extract some more feature as well. For example, when we talk about Weibull distribution, so there is a factor gamma. It is called as a failure free operation period. Failure free operation period. असं त्याचं नाव आहे. So what is its meaning? Its meaning is if we put the battery into the operation till 1148 cycles, that battery will not fail. That is assured life. That gamma is also called as assured life for Weibull distribution. So, can we give warranty of 1148 cycles to that battery? Because we have data, we have model. That model says put this particular battery into operation till 1148 cycles, battery will not fail. So I can give that as a warranty period. Can you say? थोडंसं आधी येणार. Can we say 110 or 1000 is the warranty life? Better option, right? So warranty estimation, can we call it as a feature? And this particular model helped me to find out what would be the warranty of that battery. Is it fine? This is a feature extraction. Now this about battery warranty period. Next question is what is the expected life of the battery? ठीक आहे, वॉरंटी दिली, मोबाईलला दिली वॉरंटी 1 वर्ष, फाईन. पण मोबाईल चालेल किती वर्ष सरासरी? सो सिम्पली टेकिंग द ॲव्हरेज every time is not a good approach. Simply taking the average. Why? I will tell you afterwards. But Weibull distribution also tell you what is the expected life of the battery, because there is a mathematical equation. If we get these parameters beta, eta, gamma, there is a well-known formula for model Weibull distribution which will give you the expected life of the battery as 1296. So this is another feature. Warranty is first feature that we extracted. Expected life is another feature that we extracted. Is it fine? So, did you understand application of AI in live prediction? So, feature extraction and selection. So, straight line, second degree parabola, exponential, Weibull, normal, all these are features. We extracted all the features and we selected Weibull as the best feature. Again, warranty, expected life, so many such parameters are there. These are the another feature, and we extracted those feature as gamma. 1000 cycle is a warranty. Expected life is 1296. Is it fine? And one more thing I told you that every time just taking simply the average of this number, तुम्ही तुमची पर्सेंटेज कशी काढता? सगळ्या मार्क्स विषयांचा ॲव्हरेज काढता ना. आणि मध्यंतरी गव्हर्नमेंटनं काय केलं? बेस्ट ऑफ 5. येस सर नो? दे केम अप विथ बेस्ट ऑफ 5. आर दे फुल? नो. There is some scientific reason behind it, right? So why simply we cannot rely on average? I will tell you very simple example. What is the average of 5 and 5? What is the average of 6 and 4? What is the average of 7 and 3? 8 and 2? 9 and 1? 0 and 10? सगळीकडे 5 आहे ना average. पण समजा 4च्या बिलो जर फेल क्रायटेरिया असेल आणि 4च्या वरती 5 असेल, याचा पण average किती आहे? 5 आहे. याचा पण average 5 आहे. पण हा काय फेल आहे ना विद्यार्थी. हा काय पास आहे. So can we rely on simply just taking on average? Really, every time, I'm saying every time we cannot rely on average. This is a typical example. This is a better example where we can rely on average. Here also we can say that average is a better option. But when we talk about these two, three values, we say that no, average cannot be a good option in those cases. So I am telling all these examples so that when you go into the industry or anywhere, एखादा नंबर भेटला ना तर ते हा एवढा नंबर म्हणजे हे यू नीड टू रीड फ्रॉम दॅट नंबर what that number is trying to tell you. So that approach is very important. What time is it? We have time. Okay, we'll take some more example. Only three examples are there. Okay, I know it's very difficult to listen continuously for a long time. So in autonomous vehicle, okay, so this car is there, let's say autonomous car. Okay, this is another car in front of it and this car has to overtake and this is autonomous car. So can anybody tell what feature it will take?
The
Yes.
sound frequency.
Hmm?
So I was going through some about the so they release sound waves and the frequency gets back so that it can you can tell what all solid what distance is there and then based on that you can
But what is feature in that?
motion.
So speed of this particular vehicle is one feature, speed of this vehicle is another feature. This is one feature. Second feature could be, see, when we talk about this car, let's say next time it may be a two-wheeler, next time it could be a truck. And again, if we take a car, then it has a height as well as width. So while taking a turn, which is more important feature, height or width? Width is more important, right? So two features we have, height as well as width. Which will you select? Width. Are you getting? So this particular car or this system will try to explore different feature, out of which it will extract width as an important feature to decide how much it should deviate from its path. Second thing, speed. What is the speed of this vehicle? What is the speed of the autonomous vehicle? With what the speed it gets to overtake so that it will go ahead. Clear? Any doubt in this example? Feature, extraction, and selection. And how it will come to know whether it is a truck or a two-wheeler or a car? How it will come to know? Yeah, first of all, you need to train that autonomous vehicle. ह्या वेगवेगळ्या कारचे जे काय विड्थ असतात, हाईट असतात, त्या इमेजेसनं ट्रेन केलं पाहिजे. ठीक आहे, ते ट्रेन करून करून त्या मॉडेलला कळेल की इतकं विड्थ असेल तर हा हे कार आहे, इतकं विड्थ असेल तर दिस इज अ टू व्हीलर, इतकं विड्थ असेल तर दिस इज अ फोर व्हीलर. सो दॅट ट्रेनिंग इज रिसर्च and based on that training, when it will capture an image, just he said it will send some web, it will reflect back, and or it will take simply a picture.
सर एक्चुअली प्रोफेसर ने ये रोबोटिक्स में प्रोजेक्ट किया था तो मूविंग व्हीकल विदाउट एनी रिमोट so through sound waves it will release and there was a receiver
Yeah.
which will take that and based on the feeding it will see what distance to the next object.
Yeah, right. Yeah, so similar principles are used and feature extraction will be there. Again, we can take another example of traffic signal. right? First of all, we need to train for three different colors and for their intensity of light. And when a car is moving, autonomous car, it will capture these images. It will also receive the information of intensity, and it will decide which bulb is on. If it is red, it will make a decision to stop. If it is a yellow, it will go slow cautiously. If it is a green, it will go with a stated speed. So these are the three colors, means three features. It will The car will extract this information, and accordingly it will make a decision. So these are the three features. Based on the intensity of light, feature extraction will be there, and accordingly decision will be taken. वेळ किती झाला? We are about to complete. Okay, quickly we will take two examples and we will stop. ठीक आहे. रोबोटिक सिस्टम मध्ये, सी इन दिस पर्टिक्युलर फिगर व्हॉट यू कॅन सी, different types of objects are there. Can you see?
Yes, sir.
So the robotic system has to pick that component and place at another place. So the hardness of different object is different. So that hardness is one feature. Accordingly, that robotic arm has to decide how much force he has to apply. Right? Feature extraction and selection. And for that there is, you can see there is a camera. Or maybe if that system knows only a particular component is there, then it is a predefined program. Okay, so these are the some of the examples. Last example could be yield enhancement in manufacturing. So this is again very interesting. So I hope you have a little bit experience on working on lathe machine. lathe machine में काम किया है क्या? नहीं, तो online you are typical online engineers. So लेथ मशीनचा नंतर व्हिडिओ बघा. काय होतं, जॉब असतो, स्पिंडलवरती माउंट केलेला असतो, स्पिंडल रोटेट होत असतो, टूल येतं आणि मशीनिंग ऑपरेशन होतं. ठीक आहे, म्हणजे मटेरियल इज रिमूव्ड अँड अप्रोप्रिएट शेप इज गिवन. आणि एकानंतर एक मशीनिंग झालं की तो कामोड काढला जातो, दुसरा टाकला जातो. हे कंटिन्युअस चालतं, दिवसभर चालतं, दररोज चालतं. सो वॉट एव्हर कॉम्पोनंट्स आर देअर ऑन दिस स्पिंडल, फॉर एक्झाम्पल जे कटिंग करणार टूल आहे, ते काय दरवेळी थोडं तर थोडं मटेरियल त्यातलं रिमूव्ह होणार आहे. सो विअर आउट मेकॅनिझम इज देअर. ह्याच्या आतमध्ये बेरिंग्स असतील, कंटिन्युअस फिरते, लोड इज देअर. इट इज ऑल्सो डिटोरिएटिंग ओव्हर द पिरियड ऑफ टाइम. सो what you can do as an engineer, or what will be the feature extraction, you may be interested to know what is the life of the bearing, or you want to predict whether the bearing is working or failed. Right? Bearing तर आतमध्ये आहे, बाहेरून दिसत नाहीये. So how will you find out whether that bearing is working or not? Noise, one of the feature. So noise is one feature. Based on that we can predict if there is a failure of that bearing. Good. But consider a mass production system, so many machines are there, you cannot get that particular noise.
Motion, speed.
Speed will be there, speed will be achieved. But yeah, of course, this could be another feature. Because of the failure of the bearing, there may be a slight deviation in the speed, but it's very difficult to predict whether it is a failure of the bearing. Any other feature? Accuracy. So whatever component is manufactured, so if the bearing is failed, then definitely there is increased vibration level. So that mounted component is also vibrating. So during machining, whatever accuracy you are expecting from that component, you will not get it. So if bearing fails, vibration will increase. If vibration increases, the component will tell you some symptoms. It will show that there is some problem in the bearing. जसं तुम्हाला ताप आला की इट इज अन इंडिकेशन की तुम्हाला कोविड असू शकतो, किंवा व्हायरल असू शकतो, किंवा डेंग्यू असू शकतो. तसंच इथं फीचर काय आहे, द deviation in the dimensions. And one of the good indication is chatter mark. जर बेस्ड ऑन माय एक्सपिरियन्स वेन आय वॉज वर्किंग इन द इंडस्ट्री, ज्यावेळी बेरिंग हा फेल होतो तर त्या मॅन्युफॅक्चर्ड जॉबवरती चार्टर मार्क यायला चालू होतात. आणि जर त्या वर्करला लक्षात आलं की अरे त्याच्यावरती चार्टर मार्क आलेले आहेत, तर तो मेंटेनन्स इंजिनियरला सांगतो की देर मे बी अ इश्यू रिलेटेड बेरिंग. बट दिस इज अ व्हिज्युअल. ठीक आहे, आपल्याला स्मार्ट सिस्टम बद्दल बोलायचं. माणूस नसला तर कसं ओळखायचं? सो व्हॉट यू कॅन डू, यू because of the bearing failure, again shaft may vibrate in vertical direction, that spindle may vibrate in vertical direction or in horizontal direction. So you will put a vibration sensor on top side to measure how much vertical vibration is there. You will put another sensor in horizontal side so that you will come to know how much horizontal it is vibrating, and you will set a cutoff. If the vibration is level is below certain value, absolutely fine. If it is going beyond that value, maintenance has to be carried out. So horizontal vibration, one feature, vertical vibration, another feature. We are putting sensor, and based on the vibration value cutoff, we are using the decision tree and making appropriate decision. Clear? Okay, so thank you very much. This is the end of unit number 2. If you have, if you still have energy, you can ask question. Otherwise, we will take your attendance.